At first, it looked like noise, just another misfire in a stream of distant measurements. But then, the signal moved, deliberately. It was first logged as a routine observation of 3I Atlas, one of only 3 known interstellar visitors ever recorded by human instruments. But within hours, a quiet alert rippled across NASA's internal telemetry boards. Anomalous motion detected. Vector adjustment inconsistent with natural trajectory. The object wasn't drifting. It was correcting course. An interstellar object that shouldn't be able to maneuver. A signal that wasn't supposed to exist. And a question no simulation could yet explain. What, exactly, is moving toward Earth? If mysteries like this pull you in, if you find yourself watching data turn into questions no one can yet answer, hit subscribe and like so you don't miss the next analysis drop. And tell us below what you think this object could be. Natural, artificial, or something else entirely. Because what you notice might be what everyone else missed. To understand what's moving toward us, we need to rewind the sky. July 1st, 2025. An automated telescope in the Atlas survey chain, perched high above Hawaii's Mauna Loa Observatory, spots a faint smear of light that wasn't there the night before. No fanfare, no alerts, just a pixel, whispering change. At first, the algorithms tagged it as a newly cataloged cometary body, routine. But when orbit calculators began to project its path, something didn't fit. Its trajectory wasn't looping, it wasn't bound to the sun, it was hyperbolic, an open curve slicing clean through our solar system like a stone skipping off water. That meant one thing: this visitor came from outside. Within 20 minutes, its preliminary designation pinged every observatory in the international network. C 2025 G3 3I Atlas. Interstellar origin, probable. Only the 3rd such object ever confirmed. And the first one to behave like this. The first readings placed it at roughly 135,000 miles per hour, inbound on a steep vector toward the sun's perihelion, its closest point, expected late October. Every hour brought refinement. Speed confirmed. Eccentricity locked. Brightness curve steady. Nothing strange. Until the fluctuations began. Photometric data from Gemini North revealed faint but rhythmic pulses, as if something on the object's surface was reflecting in intervals, not random scatter. Think of a distant lighthouse beam catching a telescope mirror once per rotation. A pattern in the noise. That's when NASA's Solar System Dynamics team pulled the raw logs, somewhere around the 2-hour mark of the observation run, at exactly 4:22:09 UTC. One of the analysts noticed a deviation in the object's path, a delta V, a change in velocity, of roughly 2.8 millimeters per second. That's small, minuscule even. But in the vacuum of interstellar space, unprovoked acceleration doesn't happen by chance. They logged it, flagged it, then archived it. For weeks, the entry sat in silence, buried in the daily flood of comet telemetry. Until August 6th. That's when Hubble turned its lens toward 3I Atlas, expecting to see what every comet shows: a glowing coma, a tail pushed away from the sun. Instead, the cameras saw the impossible: a narrow jet, bright, deliberate, reaching toward the sun, a plume that should not exist. The timestamp matched that same deviation logged weeks earlier. The implication: it hadn't been an error. The object had thrusted itself sunward. From that moment on, 3I Atlas stopped being a curiosity and became a priority. The tracking request was elevated, infrared arrays repositioned, and a quiet interagency line lit up across continents. Astrophysicists, propulsion specialists, exobiologists, all staring at the same anomaly, trying to answer the question that no simulation could yet explain. Was this a comet or a course correction? To understand what made 3I Atlas change its course, we have to see what the machines saw. The first clues didn't come from a telescope, but from the network behind them. A lattice of instruments, Earth-based, orbital, and deep space, linked through NASA's Interplanetary Object Monitoring System. Each night, It stitches together fragments of sky into a single evolving mosaic, a cosmic time lapse thousands of gigabytes deep. Every pixel is time-stamped, every motion quantified. When the Atlas survey logged the anomaly, the data cascaded automatically into the Minor Planet Center's pipeline. Nothing unusual, until the filter scores began to spike. Normally, a comet's residual acceleration, caused by jets of evaporating ice, registers in predictable patterns. A push away from sunlight, a tail dragged by solar wind. But 3I Atlas defied every expectation. Its vector wasn't away, it was against. A faint, steady impulse directed sunward. The math didn't cooperate. If the plume were natural, it would have to eject gas 10 times faster than any measured outgassing in history, and from a side of the nucleus that physics says should stay inert. So NASA's Deep Space Photometry Lab initiated a cross-check. They compared the optical data with infrared flux, the subtle warmth radiating from the coma. If the push came from sublimation, ice turning directly into vapor, the heat signature should spike. It didn't. Instead, the infrared curve dipped. The comet was cooling, even as it accelerated. That's not how comets work. When they fed those numbers into the Comet Dynamics Simulator NEOWISE 3, the software refused to converge. The code literally threw an exception. Non-physical input, negative thermal coefficient. In plain terms, the object's behavior made no physical sense. The next step was verification. Independent observatories, Gemini North, Subaru, and the Las Cumbres network, were asked to run astrometric triangulations, measuring 3I Atlas's position against background stars. When those tracks were combined, the residual motion was unmistakable. A constant acceleration aligned perfectly with the impossible jet seen by Hubble. At that acceleration, over 24 hours, the object's trajectory would shift by several kilometers, enough to register. So, what mechanism could create such a push? If it's natural, it should follow one of 3 known processes. 1. Outgassing, vapor jets pushing off volatile ices. 2. Solar wind interaction, charged dust grains accelerated by magnetism. 3. Gravitational perturbation, subtle tugs from passing bodies. Each was tested. Each failed. The acceleration persisted, directional and stable for 10 straight days. Not chaotic, not stochastic. Controlled. It looked like propulsion, but without a power source. Then came the strangest correlation yet. Telemetry logs from NASA's Parker Solar Probe, then transiting the inner heliosphere, recorded faint, repeating radio emissions near the same region of space. Broadband, short, unmodulated. At first, engineers dismissed them as background interference. But when cross-referenced with Atlas's trajectory, the bursts lined up within hours of each sunward acceleration spike. It could be coincidence. It could be an echo, solar particles scattering along magnetic lines. Or it could be a symptom of a system no one yet understands. Imagine a machine hidden beneath miles of ancient ice, something that's been traveling between stars for eons, reactivating only when it feels the warmth of another sun. Of course, that's speculation. Dangerous, seductive speculation. The official statement remains cautious. 3I Atlas exhibits non-gravitational acceleration likely due to localized outgassing. But every instrument disagrees with the math behind that line. Every model, except one, a new one, built not from chemistry, but from engineering principles. The question now shifts from what moved it, to who, or what, built it to move it all. Before the headlines, before the speculation, there were just people. Tired eyes staring at screens, chasing an anomaly across a sky too big to make sense of. At NASA's Solar System Dynamics Lab in Pasadena, the night shift was almost over when the message came in. Request verification of sunward emission, 3I Atlas. At first, no one reacted. Data irregularities happen every night. But then the secondary report appeared. Same vector, same timestamp, same impossible direction. For Dr. K, the lead orbital analyst on duty, it was the 4:22:09 UTC data point that froze him mid-sip of coffee. The object's residual acceleration wasn't noise. It was deliberate. He whispered one word under his breath. "No way." Then he called in the rest of the team. Within minutes, lights flicked on across the operations wing. Monitors glowed with rows of numbers. Right ascensions, declinations, delta velocities, each one whispering the same truth. Something was pushing this comet toward the sun. By sunrise, the message had reached the Jet Propulsion Data Center. Within hours, Hubble's director of operations signed off on an emergency target allocation. No press release, no public log entry, just a quiet note in the system. Object of interest, dynamic anomaly confirmed. Imagine being one of them. You've trained your entire life to explain the sky, to find order in chaos, and now the data refuses to obey your equations. In private chat threads, the tone shifted from technical to philosophical. If not outgassing, then what? Could the sun itself be causing it? Why does it match the Hubble jet direction perfectly? Someone wrote, half joking. Unless we're looking at a maneuver. The reply came instantly. Don't say that word on the network. Meanwhile, outside the official channels, the discovery began to leak. A data intern in Hawaii mentioned a weird comet in a private astronomy Discord. Screenshots of spectral readings found their way to Reddit. And somewhere between curiosity and chaos, the word propulsion entered the public conversation. NASA's communications team went into containment mode. They issued a brief, sanitized statement. Object 3 I Atlas exhibiting atypical outgassing behavior. Further observation required. But the internal memos told a different story. There was a line, highlighted, redacted in later versions. Observed impulse magnitude exceeds sublimation model by factor 9.8. Recommend alternate interpretation. Alternate interpretation. 2 words that changed everything. The next morning, at 9:12 local time, Dr. K's voice recorder captured a note to self. It's one of the few first-hand accounts we have from those 48 hours. It's not random. It's not a flare or fragment rotation. It's like something is pulsing under the surface, something that knows where the sun is. If that's true, we're not looking at a comet anymore. We're looking at intent. For the scientists inside the network, that realization wasn't excitement, it was dread. Because if the motion was intentional, it meant one of 2 things. Either nature had just revealed a force we've never recorded before, or someone else had. One researcher compared it to a heartbeat on a distant EKG. A rhythm, faint, consistent, impossible to ignore. She called it the human signal. Not because it was coming from us, but because it made them feel something that no data set ever had before. A mirror in the dark. That night, someone pinned a single line on the whiteboard above the main console. It read, "If it's watching, what does it see?" The next morning, the cameras pointed back up. And the story of 3 I Atlas was no longer just a scientific anomaly. It had become a mystery shared by everyone on Earth. Every mystery divides the room. And 3 I Atlas, this object that bent sunlight, defied gravity, and changed course, has done exactly that. By late August 2025, 2 camps had formed, each confident, each incomplete. The first group, the naturalists, believe that 3 I Atlas is exactly what it looks like, a comet. Just one behaving at the far edge of known physics. They argue that what we saw wasn't propulsion, but outgassing amplified by geometry, composition, and sunlight. A comet's surface isn't smooth, it's fractured, like an icy honeycomb. When sunlight strikes a deep vent, volatile gases trapped beneath can erupt in jets. If those vents face the right direction, the escaping material can push the body, slightly, like a microscopic thruster. But that's the problem, slightly. Models suggest such jets should cause random, tumbling motion. Yet 3 I Atlas showed directional stability. The plume didn't wander, it persisted. 10 days straight, sunward, unwavering. To fix this, researchers proposed extreme outgassing anisotropy. In plain terms, one giant vent firing continuously from a frozen canyon. Possible, yes, but the heat curves don't agree. The surface never warmed enough to sustain that thrust. So, the naturalist model works, if you're willing to bend the math. Others blame the sun itself. They point to solar wind eddies, chaotic magnetic curls that can twist ionized gas tails, even reverse them. A rare event known as reconnection. The Parker Solar Probe recorded minor turbulence during the same week the anomaly was first logged. Coincidence? Maybe not. But the problem is scale. 3I Atlas's plume wasn't gas. It was dust. Millimeter-sized grains that barely respond to magnetism. In other words, too heavy to turn. It's like trying to steer a freight ship with a paper fan. So while elegant, the magnetic theory can't explain the acceleration. It can twist a tail shape, but it can't push an object through space. Then there's the theory that nobody wanted to write down, but everyone kept whispering. What if the plume wasn't a vent or a flare, but a controlled burn? The artificial propulsion hypothesis suggests that 3I Atlas isn't a natural body at all, but an engineered craft disguised in cometary ice. Under this scenario, a reflective outer shell, thin as frost, could conceal a compact reactor or cold gas thruster array. When sunlight reawakens the systems, it vents in brief pulses, adjusting its course. It sounds like science fiction, but the math fits disturbingly well. A continuous impulse of approximately 4 millinewtons over 6 hours produces a trajectory shift identical to the one measured. And the spectral composition, CO2 dominant outgassing with isolated nickel vapor, mirrors known cold gas propellant behavior. Nickel without iron, dry ice without water. It's the perfect camouflage. Of course, skeptics remind us, correlation is not design. Coincidences stack easily in the vastness of space. But the same pattern, impossible motion, anomalous chemistry, has now been seen twice. Oumuamua in 2017, 3I Atlas in 2025. 2 data points in one lifetime. That's enough to form a line. Is the universe mass-producing objects that mimic technology? Or are we watching technology that mimics nature? Maybe both answers are true. Maybe every civilization that learns to move between stars eventually learns to hide in plain sight. What if these aren't visitors in the sense we imagine, but relics? Old, silent machines drifting from system to system, waking only when sunlight touches them again. The competing theories continue to evolve, but behind closed doors, the debate has shifted. It's no longer just what caused the thrust. It's why it happened near Earth's orbit, and whether it was meant to be noticed. By December, the trail of 3I Atlas should have gone cold. Its orbit carried it beyond Mars, fainter each night, its light curve slipping below most telescopes' detection thresholds. Officially, the investigation was over. Unofficially, it was just beginning again. Because that month, a sliver of new data surfaced, and it changed everything. NASA's James Webb Space Telescope, which had been granted a single discretionary slice of observing time, captured something no one expected. A flare. Brief. Coherent. A flash of infrared emission lasting just 47 seconds. That spike came not from the trailing tail, but from the nucleus itself. The flare wasn't random. It was aligned, perfectly, with the same vector as the sunward jet first seen in August. 4 months later, hundreds of millions of kilometers away, still pointing in the same impossible direction. Something inside 3I Atlas had reactivated. When the spectra were decomposed, analysts found a narrow absorption notch, a gap in the light where specific wavelengths vanished. Normally, that means certain molecules absorbed the light, but this gap matched no known natural compound. The pattern corresponded instead to nickel oxide at extremely high purity, a refined metal oxide, not an unprocessed mineral, the kind used in high-temperature exhaust shielding. For days, the team hesitated to publish. Then, under peer review, one quiet notation slipped through in the supplementary file. Spectral signature consistent with engineered surface material, non-confirmed. It was the first time an official NASA document had even hinted at design. 3 events, 1 vector, a precision alignment that no random outgassing model can sustain across 3 months and 500 million kilometers. The odds of that happening naturally? Less than 1 in 10 million. That's when the rumors began to leak again, this time from inside. A cached email chain surfaced between two scientists attached to the Planetary Defense Coordination Office. Dr. M. The December flare shows artificial symmetry. Should we escalate? Dr. T. Not until we rule out instrumentation drift. But yes, it looks deliberate. And then came the clincher, the orbital correction. Cross-referencing radar pings from the Goldstone Deep Space Complex, analysts detected a subtle shift in trajectory. Not a drift, a turn, roughly 0.7 degrees off the projected outbound path. A clean, controlled bend toward the ecliptic plane. Toward us, it's small, barely a whisper across cosmic distances, but unmistakable. An interstellar object that was supposed to be leaving was now adjusting course. NASA's official update, released 2 weeks later, omitted that final data point. The public file reads only, 3I Atlas is now below optical magnitude 23, tracking discontinued. But the engineers who built the tracking models kept watching. They noticed faint returns in radar backscatter, too weak to triangulate, but enough to suggest structure. The radar didn't see a fuzzy nucleus anymore. It saw edges in an object billions of years old. That's when a single classified memo crossed to the Small Bodies Assessment Group. Title line redacted, but one phrase still visible. Recommend reclassification, transient interstellar technology candidate. Whether that phrase was a joke, a placeholder, or something else, no one outside the agency knows. But it marks a turning point. For the first time, an official scientific body had to consider the unthinkable. That 3I Atlas might not be an accident of physics, but a message of engineering. And if that's true, the question changes from what is it to why did it move closer? By early 2026, 3I Atlas should have been gone, a fading speck drifting back into interstellar dark. Instead, the last radar ping showed something else, a faint correction, a turn, not random, not natural, intentional. The trajectory now hugs the ecliptic, the plane of Earth's orbit, not for collision, for alignment, as if it wants to stay in view. 3 interstellar visitors in less than a decade, after billions of years of silence. Too soon for coincidence, too perfect for comfort. If these are natural, our physics is missing a chapter. If they're not, then we're already part of someone else's experiment. The object is still out there, dimming, but not gone. And every few nights, in the same narrow wavelength as that December flare, a flicker reappears. Not random, not yet explained. If something from another star is moving toward us, the question isn't why it came, it's when it stops.